Very good morning, sir. My name is M. Varshasri. I'm studying in first BTech second semester in CSM branch, and my roll number is 234G1A33I1. Today I'm here to give a PowerPoint presentation for the CAA 2 assignment for the subject data structures on the concept of backtracking. The introduction to the backtracking. Backtracking is a problem solving algorithm technique that tries to build a solution incrementally, one piece at a time. It is particularly useful when a problem can be broken down into a series of smaller decisions or the choices. Backtracking involves systematically trying all the possible solutions until the correct one is found. How the backtracking works. The backtracking works by exploring all the potential solutions to a problem. At each step, the algorithm makes a decision and move forward, and then the backtracking when it reaches a dead end. The algorithm maintains a state or a path that continuously updated as it explores from the different possibilities. Here in the example where yes is the starting point and I1, I2, I3 are considered as the intermediate checkpoints. Here we are searching for the feasible solution, that is the S3, and S1, S2 are not the feasible solutions. From starting from the start point yes, we reaches the S1 via I1, where S1 is not a feasible solution. So then we eliminate that and backtrack through I1 to S, and we change the path to S2 via I2. And here again the S2 is not again the feasible solution, and then we again backtrack through S from I2, and then again we change the path to find the feasible solution. Then we reaches the S3 via I3, which is the feasible solution. The backtracking works very efficiently. The key components of the backtracking. The candidate represents a potential solution at each step of the algorithm. The constraints, conditions that must be satisfied for a candidate to be considered a valid solution. The backtrack, the process of undoing a decision and exploring a different path when a solution is not feasible. The applications of backtracking. Backtracking is commonly used in the problems involving combinatorial optimization, such as the traveling salesman problem. It is also used in the various Sudoku solvers, n-queen problems, and cryptarithmetic puzzles. Backtracking can be applied to the problems where the solution space is too large to search exhaustively. The advantages of the backtracking. Backtracking is a systematic and exhaustive search technique that guarantees finding a solution if one exists. It is versatile and can be applied to a wide range of problems in the various domains. Backtracking can handle the problems with the complex constraints and dependence efficiently. The many advantages of backtracking can lead to get the feasible solutions very quickly. The limitations of the backtracking. Backtracking can be computationally expensive, especially in the problems with a very high search space. In some cases, backtracking may lead to the unnecessary exploration of paths that do not lead to a solution. It may not be suitable for the real time applications or the problems where the solution space is too vast. The tips for implementing backtracking. First, define the problem space clearly and identify the decision points and the constraints. And the next step is design a recursive function that explores all possible solutions incrementally. The third step, using pruning techniques to eliminate the unnecessary branches and optimize the search process. The backtracking, which is considered as the best technique. Backtracking is a more intelligent search technique compared to any others as it uses the constraints to guide the search. Brute force involves trying every possible combination without considering constraints or making informed decisions. Backtracking is more efficient in finding the solutions to the complex problems with the multiple constraints. The applications in the real world. Backtracking is used in the artificial intelligence, the robotics, and the computer vision for both planning and the optimization. It is employed in the natural language processing for grammar parsing and the spell checking. Backtracking is also utilized in the network routing algorithms and resource allocation problems. The conclusion. Backtracking is a very powerful algorithmic technique for solving through systematic exploration of the potential solutions. By leveraging constraints and intelligent decision making, Backtrack can efficiently navigate the complex problem spaces. Understanding the concept of backtracking and its applications can enhance the problem solving skills in the various domains. Though the backtracking have the disadvantages too, but the backtracking technique is a very powerful algorithmic technique for solving the very high dead end problems. Thank you for giving me such good opportunity.